Welcome everyone. Thank you for attending. My name is Maxime Huynh, and I will be talking about how you can build a cross-platform and automating testing suite for video workflows. So first of all, who are we? Well, we are Lumen Technologies, formerly CenturyLink and formerly StreamRoute, because we got acquired last year by CenturyLink, and we focus mainly on client-side video delivery optimizations. Our first and main product is a WebRTC-based solution that enables hybrid CDN and peer-to-peer by wrapping the video player. So think about any type of product you have some new features available and you would like your customers to benefit from them. Everything is working great locally, but in real life, there are a lot of ways that this could break in production. The first of all, when you think about video workflows and video delivery products, is that you have lots of integration layers. Just for web, you have more than 10 video players available. They each have their own versions. Then you have the stream format, the operating system. Then you have mobile devices. So they all bring new potential ways to break your product or your code. The other thing is you have high dependency on flaky network conditions. Of course, if you have a nice fiber condition, everything should work perfectly. But what happens if you are in the countryside or if you are on 4G? Or even worse, what happens, and even more important, what happens when you have high evening spikes and when, for example, your backend is scaling? You want to be able to make sure that everything is working great on all those conditions. And to be honest, more importantly, the real topic here for me is how not going crazy while testing all this, because it's more like 100,000 use cases and anyone would go crazy while testing all this. Here you can see what we had before, which is basically a to-do list within a Confluence page. And we would test playback and stability, controls, and all the different types of use cases we have. And the very bad thing is that it took us basically half a day for just non-regression and for every client release. There were no specific tests for external dependencies. Reports, as I said, and as you can see, were manually filled and frankly not very pretty. And some use cases were just not tested because it was so time consuming. The very nice thing, and that's the story we're going to talk about today, is that now all this takes us basically 1 minute or 2 clicks on Postman. All the tests are done automatically and all the results are aggregated within a test trail, which is a nice QA tool for aggregating reports. Again, we have also some listeners that fire test every time we have a new external dependency update. And some use cases now can be tested and very easily added to a routine and become systematic by anyone within the team. So this is the overall landscape of what you need if you want to build such workflow for QA automation. And the first thing you need is some testing material, right? It's, for example, in the case of web, you want to easily be able to launch some web pages on any type of browsers, on any type of operating system. And it's the same for mobile applications. And so we designed a custom tool called a web page generator, which is basically an API that generates web pages on the fly. And the other thing we developed, and because there is no such thing as async loading on mobile devices, we designed an iOS and Android app that includes everything. So all the different types of modules, so players and SDK and a specific configuration. And it looks like the following. Basically, for web, it's an URL with some query params, and each query param corresponds to a specific module or a specific version of a module. And on mobile, it's the same. We added the capability to handle deep links within our apps, which allows us to also have a URL type way of launching the app and having some parameters within query parameters. The second thing you'll need is a way to automate human behavior, and this is done using some famous tools such as Appium and Selenium. And you will also need some devices, of course, to be able to receive this testing material. So here you can see what we call the orchestrator, and it's basically some custom code in charge of making sure the overall QA automation is working perfectly. First of all, he's going to be the one in charge of generating the web page for web browsers or the QA app for mobile devices. And he's connected to two types of hub. And the first one for mobile devices is an Appium hub. And this is the tool we use to first of all install the application, launch the application, mimic some human interaction, and actually launch the stream. On the website, it's the same principle. In this case, it's a web page, so it's basically the URL we just showed you. And the orchestrator will send this URL to the Selenium Hub, and the Selenium Hub will be in charge of launching the web pages on Firefox, Chrome, etc., etc. So once the run are done, there are some logs generated, same on devices and same on web browsers. And then again, the orchestrator is in charge of taking those logs and making the tests. The other important thing to mention is that we have two types of device pools available. The first one is located at the office and is composed of real browsers. We have some machines or actual phones that you can see on the picture. And it's great because you make your test in basically the same conditions as your customers. The bad thing is that everything needs to be managed manually, right? If you have some new web drivers updates or browsers updates, you need to do them manually. And the other thing when you think about an office is you have power out gauges, you have Wi-Fi disconnections. And this could make some tests failing, but there is nothing related to your product. And the third great thing is that you have eyes on it, and it's great for confidence to actually see and to have everybody see within the team that your product is working right. So we use it for actual releases. Every time there is some new features that will be delivered to the customer, we make sure everything is working right on real devices. The other device pool we have is in the cloud. So the bad thing is we do have some real devices for mobile, but for browsers, we are using some containers. And since Docker is a Unix-based environment, we can't have any Safari or Internet Explorer, so Mac OS or Windows environments. And but the great thing is that it's always up since it's managed by Google or AWS, and we can. This allows us to bring some automation and automated triggers. For example, I mentioned that we were making some tests for external dependencies update, and this is done using this type of cluster. And the other thing is that you have some Kubernetes magic. So again, for automation, it's perfect. You have cron jobs. You can have as many browsers as you want because you have some auto scaling and HPA for those who know. So this type of device pool, we use it for periodic tests, like for example, every night, every weekend for triggers, as I mentioned, or for tests that are triggered by the CI when you have a new pull request, for example, on a specific branch. So the third thing you'll need is a way to actually do the tests and to do some reporting, of course. So this is where we are going to script all the assertions, such as you should not have any fail request, or you should be able to play, pause, and seek. You should be having some CDN download. You should be able to make a range request. We're using a specific framework called Jasmine. It's not particularly important. There are a lot out there, and you can choose any type of framework you would like. And then each result is then sent to TestRail using their API. So each assertion you can see here is going to be a result line within the TestRail dashboard. And this is done again using the orchestrator, because he's the one making sure that everything is working great and in charge of making the communications in between everyone. And last but not least, so this famous orchestrator. So as I said, the orchestrator is some custom code, and it's designed and developed in Node.js. And first of all, it's the main entry point for a common API for mobile and web. And eventually, we want to be able to test some smart TVs and game consoles and other platforms. And you saw that there are a lot of moving pieces. And to me, it all looks like a domino chain, and this orchestrator is in charge of making sure everything is working smoothly. So as we previously mentioned, he's the one in charge of generating the web pages and to download the app with the proper modules. He's the one launching the jobs on the specified cluster on specified devices. And then he's also the one in charge of gathering the logs, performing the test, and sending the results. So now I would like to show you a quick demo for you to have a clearer view on how everything is working on both web and mobile. So welcome to our Postman dashboard, and this is where we are saving all the collections related to the different APIs we have. And here you can see the typical request that we will send if you want to launch a non-regression test for QA purposes. So this is pointing to two types of clusters. The first one being in the cloud, we call it the tools cluster, and is composed of Chrome and Firefox containers. The other one is the Office cluster and is composed of real browsers, real machines, with of course Chrome and Firefox as well, but also we can have Safari, Internet Explorer, Edge, and Opera. So if we look a little bit at the parameters, for example, you have the player tags, and here you can put, for example, basic QA, and for us it means we will make a QA on HLSJS, Dash.js, RxPlayer, and Chaka, but you could also just put one player, and this is what we will do in our case for simplicity purposes. You can choose the type of integration you want. This means basically the type of module you want, the version of the module. And of course, you have all the things related to the test. And in our case, we will also make a bunch of tests, including backend, playback, and other Lumen-specific tests. So I will click Send, and we will see how the Office cluster will react. Here you can see a remote connection to the machines we have at the office. I'm currently located at home. And you can see that on the top right, it's the local server where the Selenium hub is located. And you can actually see that the server did receive the JSON object we just sent, saying that we need to send some streams to Windows, Ubuntu, and macOS on the Chrome, Firefox, and the Safari browsers. So you can see that the streams are playing. We can see some peer-to-peer, which is good for us and for our tests. And once the run is done, we will receive the logs, make the test, and send the result to TestRail. The TestRail dashboard is what the end user is actually going to see. What we just saw with the VNC remote connections is usually just for debug purposes. We don't really look at the actual browsers. So here in TestRail you can see two types of projects, mobile and web. In our case it was a web test on HLSJS. If we go in milestones on test MHV, it's the run we just made, you can see the test results, and you can see that some tests have been done on Firefox, Chrome, and also somewhere Safari, and on different types of platforms, so macOS, Unix, which is basically Linux, and Windows. So if, for example, we go in Safari, you can see that some tests passed, some other failed, and this is due to the very short amount of time. We put 10 seconds. And for example, here you can see the reason of the test failing. So here some requests have not been made. So, and if there is a bug, the great thing is that you can have access to the web page link we just used to make the test, and you can use the usual tools such as the network tab or console to see here if we have some errors or if some requests have failed. So the last thing I would like to show you is how everything is working with mobile devices. So the overall logic is very much the same. We will use the same Postman collection. The results will also be available at TestRail. But this time the run will not be sent to a Selenium hub, it will be sent to an APM hub. And again, either located at the office or in the cloud. And in the case of the cloud, it's located in AWS Device Farm. So here is the AWS dashboard. We click on the project and we can see that we sent some job to either Android or iOS devices. And again, this is not for the end user because the end user is actually going to look at the TestRail dashboard, but this is great to actually understand how the overall mechanism is working. So here you can see that the device has been launched. Pretty soon you'll see some human interaction, and this is the APM script going on, yes. And eventually the stream is started. You'll see some peers connected, which is good for us and for our tests. And what is going on right now is that some logs are generated, and they will be used by the local server to make the test and eventually use the TestRail API to input the results within the TestRail dashboard. So I hope that now you have a better understanding on how everything is working and how all the pieces are working together. I would like to emphasize on the fact that this is part of a global QA workflow or global QA vision, and it needs to be within a global vision to be efficient. So non-regression tests and automation are a great way to gain confidence, but you also need to have other types of ways to gain this confidence, such as A/B testing, canary releases, unit tests. So the nice number we like to communicate is like we have around 70% of the tests that are done automatically, and we hope to increase this number more and more. But there will always be some manual QA, and especially when you think about video workflows, you always have some kind of tricky, fishy use cases with, I don't know, query params, for example, that goes into the URL. Well, anyway, so there will always be some manual QA. A few pitfalls. First of all, this is kind of lots of different technologies, lots of intricacies, and it took us like 1 to 2 months to have a stable architecture. And this is where you want to have some microservices to be able to isolate the bugs and focus on the root cause of them. Then, to me, the AWS API is kind of tricky, and to be honest, we're thinking about just having an APM hub at the office because it's not as easy as connecting to a remote APM hub. Some services are providing this, but AWS is not. And the other thing is, yeah, you have some Kubernetes subtleties if you want to have a managed cloud clusters with containers. And upcoming next for us, so we are moving our whole code base to C++ because we want to be able to handle as many platforms as possible. And of course, this means we will need to be able to test on those platforms. So currently, I'm actively working on Chromecast and other smart TVs, for example, or Android TVs such as Fire TV. But eventually, we also want to be able to work with Xbox, PlayStations, and others and be able to QA them. So here I have put, and you will have the slides, some useful links that helped us building this whole tool chain. And if you have any questions, I would be happy to answer them now or eventually using my email. Thank you very much for listening.